System Design Blueprint, the ultimate guide. Introduction. Mastering System Design Interviews. System design interviews can be intimidating, but they don't have to be. We've created the ultimate template to tackle various system design problems that commonly appear in technical interviews at top tech companies. This comprehensive blueprint serves as your roadmap through the complex landscape of distributed systems architecture. Whether you're preparing for interviews at FAANG companies or building real-world systems, this guide covers all the essential components you need to understand. From load balancing to database design, from caching strategies to security considerations, we'll walk through each element that makes up robust, scalable systems. This blueprint briefly touches on critical discussion points including load balancing, API gateway, communication protocols, content delivery networks or CDNs, database design, cache strategies, message queues, unique ID generation, scalability, availability, performance, security, fault tolerance, and much more. Let's dive into each component and understand how they work together to create enterprise-grade systems. 1. DNS, Domain Name System, the Internet's address book. How DNS works in our system. DNS resolution flow. 1. User request. When a user types a domain name, the request goes to DNS servers. 2. Authoritative Name Server, ANS. Returns the IP address 172.31.34.45. 3. Domain hierarchy. The system resolves through top-level name servers like Amazon.com. 4. Root Name Server. Provides the foundational DNS resolution. 5. Final resolution. Returns the actual server IP where the application is hosted. Key components. ANS and IP resolution. Converts human-readable domains to machine-readable IP addresses. 2. Top-level domain, or TLD. Handles domains like .com, .org, .net. 3. Hierarchical resolution. Multi-level resolution for reliable address translation. Interview discussion points. DNS caching strategies and TTL, or time-to-live management. DNS load balancing and geographic routing. DNS security considerations. DNS over HTTPS and DNSSEC. Failover strategies when DNS servers are unavailable. 2. Load balancing. Distributing traffic efficiently. Load balancing architecture. Our blueprint shows a comprehensive load balancing strategy with multiple layers. Primary load balancing components. API gateway, first point of contact, handles routing and authentication. Load balancer, multi or primary, distributes incoming requests across multiple servers. Front-end servers, handle user interface and initial request processing. CDN or edge servers, serve static content from geographically distributed locations. Load balancing strategies covered. Input validation, ensuring data integrity at the load balancer level. Authentication and authorization, security validation before request forwarding. Rate limiting, protecting backend services from overload. Weighted or randomized, different algorithms for traffic distribution. Flow control, managing request flow to prevent system overload. SSL termination, handling encryption and decryption at the load balancer. Request header validation, ensuring request validity. TLS termination, managing secure connections. Health check validation, monitoring backend server health. Retry or circuit breaking, fault tolerance mechanisms. Advanced load balancing features. Geographic routing, directing users to nearest servers. Session affinity, ensuring user sessions stick to specific servers. Auto-scaling integration, dynamically adding and removing servers based on load. 3. API gateway, the system's front door. API gateway responsibilities. Core functions. Request routing. Intelligent routing to appropriate backend services. Authentication. Centralized security validation. Rate limiting. API usage control and abuse prevention. Request/response transformation. Data format conversion. Monitoring and analytics. API usage tracking and performance metrics. Integration points. Front-end servers. Seamless connection to user-facing applications. Back-end services, routing to appropriate microservices. Security layer, integration with authentication and authorization systems. Monitoring systems, real-time performance and usage tracking. Interview considerations, API versioning strategies, circuit breaker patterns for fault tolerance, API documentation and developer experience, performance optimization techniques. 4. Communication protocols, connecting system components, protocol selection strategy, real-time communication, WebSocket for live streaming, chat applications, and real-time updates, server sent state, ASC for push notifications and live feeds, HTTP short polling, simple but less efficient real-time communication, HTTP long polling, more efficient alternative to short polling, asynchronous communication, message queues, decoupled communication between services, event streaming, real-time event processing, pub-sub patterns, publisher-subscriber messaging models, static content delivery, CDN integration, global content distribution, edge caching, reducing latency through geographic distribution, static resource optimization, efficient delivery of images, CSS, JavaScript, protocol performance considerations, latency requirements and optimization, bandwidth utilization and cost implications, security requirements for different protocols, scalability limitations and solutions. 5. Back-end services, the system's core logic, microservices architecture, service categories, core application services, front-end servers, user interface and experience layer, back-end servers, business logic and data processing, microservices architecture, distributed service design, infrastructure services, distributed ID generator service, unique identifier creation, upload-download services, file handling and storage, processing services, data transformation and computation, specialized services, notification service, user communication and alerts, analytics service, data analysis and insights, search service, information retrieval and indexing, payment processing, financial transaction handling, service design principles, single responsibility, each service has a focused purpose, loose coupling, services operate independently, high cohesion, related functionality grouped together, fault isolation, service failures don't cascade. 6. Database design, data storage and management, database architecture strategy, database selection, SQL databases, ACID compliance, complex queries and relational data, NoSQL solutions, scalability, flexibility, and unstructured data, hybrid approaches, combining SQL and NoSQL for optimal performance, data management features, database admin, administration and maintenance tools, replication, data redundancy and availability, sharding, horizontal scaling across multiple databases, backup and recovery, data protection and disaster recovery, specialized database services, document stores, JSON or document-based storage, key value stores, simple, fast data retrieval, graph databases, relationship-focused data models, time series databases, sequential data with timestamps, database optimization strategies, indexing strategies for query performance, partitioning and sharding techniques, read replica configurations, connection pooling and resource management. 7. Caching strategy, performance optimization, multi-layer caching architecture, caching levels, application level caching, in-memory caching, fast access to frequently used data, session caching, user session data storage, query result caching, database query optimization, distributed caching, Redis or Memcached, distributed cache solutions, cache clusters, high availability caching infrastructure, cache invalidation, ensuring data consistency, CDN and edge caching, geographic distribution, content delivery optimization, static asset caching, images, CSS, JavaScript, dynamic content caching, intelligent dynamic content storage, cache management considerations, cache warming strategies, TTL configuration, cache hit ratio optimization, memory management and eviction. 8. Message queue system, asynchronous communication, message queue architecture, queue management, message dispatcher, central message routing and distribution, queue management, multiple queue handling and prioritization, topic-based routing, intelligent message categorization, dead letter queues, handling failed message processing, processing workers, message queue workers, parallel message processing, processing pipelines, sequential message transformation, batch processing, efficient bulk message handling, real-time processing, immediate message handling, integration patterns, pub-sub messaging, publisher-subscriber communication, point-to-point, direct service-to-service messaging, request-reply, synchronous style messaging over async infrastructure, message routing, intelligent message destination selection. 9. File upload and processing, handling media content, file processing pipeline, upload process, client upload, files uploaded via signed URLs for security, object storage, files stored in distributed object storage, S3 compatible, processing queue, files queued for processing and transformation, content validation, file integrity and security validation,